Hello everyone, welcome to Essence Educational GMAT Plus. So today I'm going to solve a difficult GMAT Math question, an 800 level question. Again, I'm going to use our 3 strategies, and that's all we need to solve any GMAT questions. Okay, let's start. First, let's read. List T consists of 30 positive decimals. Okay, positive greater than 0. That's exactly the first thing I do, translate. I hate English words, so I want to translate them using the mathematical language. Decimal, what is decimal? Like 5.1, right? 1.1, 0.5. You have a number after the decimal point is called a decimal, okay? That's to say none of them is an integer. And the sum of the 30 decimals is S. I want to translate this sentence. If you don't know something, do you know each of these decimal points, decimal number? You don't. If you don't know something, what do? You use letters to represent the unknown. That's the basic idea of algebra. So let's start. Let's call this A1, A2, A30. Write 30 numbers. The sum is S. Let's continue. The estimated sum of the 30 numbers, okay, E, is defined. You have another number E, estimation, is defined as follows. First sentence. Each decimal in T, whose 10th digit is even, is rounded up to the nearest integer. So this sentence is pretty abstract, right? It's pretty abstract. What the hell do you mean, right? It's pretty abstract for you to understand. So how do we deal with abstract situations like this? Now that goes to my second strategy called specification. So let's start with this. When the situation, if I want to teach you something abstract, for example, what is method of difference or what is abduction in formal logic, in order to help you to get 100% correct in reading comprehension and critical reasoning, what should I do? Should I start with the theory or should I start with examples or stories? Which one is easier for you to understand? Of course, examples or stories, right? Think about it. If for those people who are good speakers, good lecturers, do they often start their presentation using stories, experiences, or examples, or they start their presentations with very abstract theories? Of course, the former, right? They always start with examples. Why? Because example stories, these are concrete stuff, much easier for human being to understand. Agree? So it's the same idea in mathematics. When the question is abstract, we can use specific examples to help us to understand the abstract situations. And that's exactly what I'm going to do here. By the way, I have one recommendation. That is, when you start to use specification, so basically the idea is plug a number into a variable. So basically you try examples. That's the idea of a specification. Examples help you. And when you try examples, I have one recommendation. You start with the most extreme, most special example first, okay? Because these examples give you the boundary, give you the help you understand the situation much better, okay, than normal examples. Let's take a look at this situation. Now, I'm going to use an example to help me to understand this sentence. For example, 0.2. The 10th digit here, you see, the 10th digit is 2. 2 is an even number, agree? So this number is rounded up to the nearest integer, that is to say, rounded up to 1. So you see, it increase 0.8. Agree? It increase. So what is the maximum you can increase? So remember, the minimum here is not 2. Agree? 0 is also an even number. That is something you must know. Agree? So what is the maximum you can increase? The maximum you can do is, let's say, 0, 0, so many 0, 1. Agree? So here, this is still a decimal. It's not an integer. You increase, 0 is an even number, so you still round it up to 1. Agree? So you increase 0.99999, so almost equal to 1. Let's say x is the amount you increase. X, the maximum you can increase, is very close to 1. Agree? So that's what I mean by most extreme example. So what is the minimum you can increase? So the minimum you can increase, okay, so this number 0.8, next one 99999, many nines, agree? Because I don't care the number afterwards, because here is 8 is even, so I still round it up to 1, okay? This number is very close to 0.9, and that's the minimum I can increase, 0.1. This 8 can't be 0.9 because 9 is odd, doesn't fulfill anymore. Get it? So the maximum, you see, that's called most extreme example. So the maximum I can increase, okay, something greater than, the minimum, sorry, I can increase is something greater than 0.1. See, that is the amount I can increase when I round up. Next sentence. Each decimal in t whose 10th digit is odd is rounded down to the nearest integer. So still I use specification, example, to help me understand the situation. Let's say 0.31. Agree? This number 3 is an odd number. So this number would be rounded down to 0. You decrease 0.31. Agree? What is the maximum you can decrease? The maximum you can decrease is 0.99999 mini-nines. Agree? This one you drop to 0. So if I call y is the number you decrease, the maximum you can decrease is close to 1. Agree? By the way, here the integer part, this can be 0, can be 9, 2, 3, can be any number x, doesn't matter. Because round down, round up doesn't care this part, right? Round up to an integer, round down to an integer, doesn't care this part. Get it? Okay, so here, then what is the minimum you can drop? The minimum you can drop, you can't be 0.0 because 0 is not an even number, so you can be 1, okay? If you have any number greater than 0 here, you drop is more than when everything else is 0, agree? So the minimum you can drop for each of them is 0.1. So 0.1 is no more than y, less than 1, okay? So here, that is the boundary you find after read and understand. The strategy I'm using, again, it's called specification. Now, let's continue to read. E is the sum of the resulting integers. If 1/3 of the decimals in t have 10th digit, that is even, okay? So let's translate this sentence. Let's say A1 till A10, okay? The 10th digit is even. A11 until A30, these 20 numbers, 10 numbers, 20 numbers, the 10th digit is odd, okay? That's the meaning. Which of the following is possible value for e minus s? You want to know e minus s, and you have numbers from -16, 6, and 10, okay? So your purpose, you want to know e minus s. So what is the difference between e minus s? Then you know, for each of them, you increase x1, okay? Goes to E1. Here you increase to E10, right? You increase X10. Here you drop because this is round down. Y1, you drop Y11, you drop Y30, okay? These 20 numbers, or you call it Y1 to Y20. That's even better. Okay, you drop to E11 to E30. So E is equal to E1 plus E30, right? Minus S is equal to A1 until A30. Agree? So E1 is equal to A1 plus A30 plus X1 plus X10. Here you minus, then you plus, okay, A11 plus A30, but you subtract the one you drop. Okay, Y1 plus Y10, Y20, okay, Y20, you drop. Okay, this is E. This as a whole is E. Then you subtract S. S is A1, A30, okay, this is 10, A1 to A10, right? So A1 plus until A10, A11, A30, this is exactly this one. So E minus S, as you can see, is equal to X1 plus X10. So those you increase, subtract those you decrease, right? That is the result. So as we know, so what is the boundary when you see this? We know each X is from what? Is less than 1, greater than 0.1. Each Y is also from 0.1 to 1. Right? From 0.1 to 1. That's each Y. That's what we know before. So what is the maximum? The maximum is the maximum of this minus the minimum of this. Agree? So E minus S is less than, the maximum is 10, minus the minimum of this is 0.1 times 20. That is 2. It must be less than 8. Okay? Greater than what? The minimum is what? The minimum is the smallest for this one, which is 1. Then minus the maximum for this one, which is 1 times 20. This gives me minus 19. So E minus S, you see, from my extreme example, I know the boundary is from minus 19 to 8. Agree? So therefore, let's come back. So 10 is wrong. Must be from minus 19 to 8. Okay? So the other two belongs to this boundary. But once I eliminate the third one, so B, C, D, E, 3 choices are gone. So I choose between A and B. So I only need to verify the second one. If I can construct an example which gives me 6, agree? Then I choose B. Otherwise, I choose A. So let me try to construct an example that gives me 6, which is pretty easy. To give you 6, okay, what do you want? 0.2, okay? 0.2 goes to 1, agree? Let's say these 10 numbers are all 0.2. So each one I increase 0.8, agree? So here you see 0.8 times 10, I increase 8 in total. In order to get 6, so I have to subtract 2 in order to get 6. Agree? So here I have to decrease 2. I have 20 numbers, so each one, 2 divided by 20, I have to decrease 0.1. So let these 20 numbers be 0.1, 0.1, 0.1. Agree? You have 20, 0.1. Each of them you run down to 0. You drop 0.1. So you drop 0.1 times 20 gives you 2. So 8 minus 2 gives you 6. We can construct an example here. We have 10, 0.2 and 20, 0.1. In this example, E minus S is equal to 6. So therefore, the second one is possible. So therefore, we choose what? We choose B. The right answer for this question is B. You see how I deal with this quite difficult question. Now, this is really quite difficult question in GMAT. Using our second strategy, specification. Some students ask me, hey, you see, you probably use 5-6 minutes or even more to answer this question, right? But you have on average 2 minutes per question for the GMAT. Yes, always remember this. Those who can get a high exam score, including GMAT, are those who can solve easy questions quickly and correctly. Then you save your time for the difficult ones like this. Agree? So normal GMAT questions, you don't need 2 minutes to solve them. So you save your time. So you do have time at the end to solve 800 level questions like this. Clear? That is for this question. I hope you start to have an idea of what is specification and how do we use it to deal with the most difficult questions. Thank you.